All right, well, welcome back to math class. We're going to continue our series on transformational geometry. Today we're going to talk about a different kind of transformation. Last time it was a translation where we slid, and now today we're going to reflect. So reflection is just a transformation that flips a figure across a line, and that line is called the line of reflection. So we can reflect it across different lines like the x-axis or the y-axis or even some other things, but today we'll keep it simple and just do x and y-axis. So go ahead and hit pause and add this to your table of contents and create a new entry in your notebook or piece of binder paper. So we're going to look at the properties of reflections, and we're going to look at how we can describe the properties of a reflection. Okay, so vocabulary for today is reflection is a transformation that flips a figure. So this is a flip across something called the line of reflection. So we have our pre-image, our starting image. We have our image, what we end up with, and we're going to flip it across the line of reflection, and that's called a reflection. So go ahead and hit pause and add this little visual and these definitions to your notes. All right, so I'm going to do one here. Normally we would get some tracing paper and do this together in class, but you know, distance learning. So what I'm going to do is I'm going to trace this triangle. Not too bad. Okay, and I am going to imagine that I'm traced it on a piece of tracing paper, and then I'm going to fold my piece of tracing paper over on the x-axis. So here's my x-axis. I'm going to fold it along the x-axis. So what I'm going to do is so I'm going to just imagine that here was my original, and then I folded my tracing figure down. And so what I just did is I reflected it. So what was my line of reflection? What do I call this line right here? That's the x-axis. And now I'm going to look how far from the line of reflection each point is. Oh, and by the way, this would be C prime, B, come on, goodness. All right, well, let's see. That's, oh my gosh, you guys. All right, A prime, B prime. You know, I'm going to be so happy to have a smartboard to write on again. It's ridiculous. So let's count. How far is it from the line of reflection here? So point A is, let's see, 1, 2, 3, 4, 5 spots away. Point B is 1, 2 spots away, and point C is 1, 2 spots away. Let's look at A prime. How far is A prime from our line of reflection here? It is 1, 2, 3, 4, 5 spots away. B prime is 2 spots away, and C prime is also 2 spots away. What do we notice? It's the same. So we're going to make sure, the moral of the story is that we're going to be the same number of units away from the line of reflection each time. How do the lengths of the sides compare? Let's see. I can count them. That's probably easier. Okay, so this line CB prime is 4 and CB is 4. Line AC is 3 and AC prime is 3. And I can't exactly do that, but it's a 3, 4 triangle. And if you remember from Pythagorean theorem, that means the hypotenuse has to be 5. And since this is 3, 4, that has to be 5. So all the sides are the same shape. Angles, what do we got here? We have a right angle. And if we're given 2 lengths and this angle right here, we know the angles are the same. And I know also because I traced this, right? I can flip it back if I want. Okay, let me flip it back and put it back there. And yeah, the angles are the same, especially if I did a good job tracing it, which I did an okay job. So the sides are the same, the angles are the same. That means it's congruent. Okay, go ahead and add these steps to your notes. Hit pause and make it happen. All right, these are the steps for graphing a reflection. Basically, we're going to count how many units each point is from the line of reflection. We're going to plot the new points the same distance from each other on the other side of the line of reflection, though. And we're going to label it with prime notation. And then we're going to connect the dots when we're all done with that. All right, so I'm going to go ahead and do one. I'm going to reflect this pentagon across the y-axis. I'm going to start with C. C is 2 points away from the y-axis, so I'm going to put C prime 2 points away on the other side of the line of reflection. B is 3 away, so I'm going to go 3 away over here and call that B prime. A is 5 away, so I'm going to go 5 away over here and call it A prime. D is 3 away, so I'm going to put D prime 3 away. And E is 5 away, so I'm going to put E prime 5 away like that. And I'm going to connect my dots. Oops, whoa, I kind of messed that up a little bit, didn't I? Erase, erase, erase. E prime goes right here. All right, and then I'm going to connect my dots carefully as I can. Boom, and there I have a lovely reflection. Okay, I'm going to do one more down here. I'm going to start with D. It's 1 away. This time I'm reflecting across the x-axis. So I'm going to put D prime 1 away as well. C prime is 1 away, so I'm going to make it 1 away, but on the bottom this time. A prime is 4 away, so I'm going to count 4 spots and put A prime. And B prime is also 4 away, so I'm going to keep right on the same x-coordinate and just slap B prime 4 away down here. Then I'm going to connect my dots as carefully as I can. And voila, I have reflected. How does trapezoid ABCD compare to ABCD prime? Well, they are the same size. They are the same shape. Are they facing the same way anymore? No, they are not. So my orientation has changed. All right, so the what if says, what if I reflected it across the y-axis? Ooh, okay, difficulty level. All right, let's start with B. B is 1 away from the y-axis, so I'm going to slap B prime 1 away on the other side. A is 3 away, so I'm going to put A prime over here. See how I'm flipping it the other way. And then D is 3 away, so I'm going to put D prime over here. And C is 3 away, so I'm going to put C prime over here. I'm going to connect my dots, not all that carefully. Boom, and there we go. So it's okay, you can actually reflect them and have them overlap on each other too. Okay, but again, it's the same size, same shape, but my orientation is differently. Like this one, the point's going to the left, whereas my pre-image, the point was going to the right. Okay, so now let's look at what's happening with the coordinates, just like we did with transformations. I'm going to start with y, okay? So y, remember, this is my pre-image, and I know because there's no prime, that's my image. Okay. So y is sitting here at, let's see, 1, 2, 3, 4, comma, -1. And y prime is sitting also at 4, but instead of -1, it's +1. Oh my gosh. So this stayed the same. This is different. We'll talk about what happened there in a minute. Let's look at z. So we'll start with z is sitting at 6, comma, -5. Z prime is also sitting at 6, but instead of -5, it's sitting at +5. So what happened here? It's not like, okay, we added 2 and we added 10. Like we want the same thing to happen. So let's not say that. So our our x coordinate stayed the same, even because we're reflecting across the x-axis. So x stayed the same, and our y's changed. So we started out negative and we ended up positive. So how can we express that algebraically? So here's the rules. If we're reflecting across the x-axis like we just did, we're going to change the y coordinate by multiplying by -1. And that basically just changes the sign of the y coordinate. If we're reflecting across the y-axis, we're going to mess with the x coordinate. We're going to change the sign of the x coordinate by multiplying by -1. All right, I added some highlighting here so that way you knew what to copy down. So here's our algebraic rule for reflections. So just copy down the highlighted part. So reflections across the y-axis, and here's our rule. Remember, we're going to change the sign of the y. Across the y-axis, we're going to change the sign of the x. Okay? And then copy down that we're going to reflect across the y-axis, and then just this little chart right here. All right, hit pause, make it happen. Okay, so let's jump in. So we have triangle PQR. So we're going to put P is 3, 3, Q is 5, -1, and r is 1 comma negative 3, like that. And we want to reflect it across the y-axis. So since it's the y-axis, we're actually going to mess with the x-axis. So our rule is right here. So our rule is we're going to take the opposite of x and we're going to leave y alone. Okay? All right, so we're going to get the opposite by multiplying by negative 1. And we're going to leave the y alone. And we're going to do that here. So we're going to multiply by negative 1, leave the y alone. Multiply by negative 1, leave the y alone, like that. And then we're going to do our math. So negative 1 times 3 is, well, hold on. I'm going to put my prime down here. P, Q, R prime. Okay, so negative 1 times 3 is negative 3, comma 3. Negative 1 times 5 is negative 5, comma negative 1. And for R prime, it would be negative 1 times 1, which is negative 1. And we leave the x, or the y alone, excuse me. All right, I'm going to hit pause and graph this just as a check. You don't have to do that. All right, so pretend it looks better in your mind, but I graphed PQR, and then I graphed my new coordinates for PQR, and did I reflect across the y-axis? Yes, I did. And everybody is the same number of units away from the line, so I know I did it right, even though my trace job was pretty sad. Okay, let's do a summary together, and then I'll have an optional video at the end, and that's it. Like I said, I'm trying to keep these kind of shorter. So reflections keep blank and blank the same, but not the blank. So what stayed the same with our reflections here? Okay, the size and shape stayed the same, but the way they're facing changed, and the way they're facing is called the orientation. So reflections keep size and shape the same, but not the orientation. And since size and shape are the same, we call that in math congruent. Hey, that's pretty darn similar to translation, right? Okay, time for a totally optional math video.
Math shorts.
Reflection is a type of movement or change in a geometric shape. Think about when you look in a mirror. You see a reflection of yourself. See how your reflection appears to be the same distance from the surface of the mirror as you are? Also note how the left and right sides are reversed. The same is true with geometric shapes. When we reflect this triangle like this, the x-axis acts like a mirror. You can reflect all kinds of shapes as long as you determine the line that you want to reflect on, just like a mirror. For example, you can use any line along the x-axis or the y-axis. You can even reflect a shape through a line using an expression such as x equals 1. In this example, the line x equals 1 is the line of reflection for the two triangles. You can use any expression to create a line of reflection anywhere. The way to make sure a shape is correctly reflected is to check that each point of one shape is the same distance from the line of reflection as the corresponding point in the other shape, and that it has corresponding sides and corresponding angles. Just like other transformations, you can record the coordinates of the shape and its image to demonstrate the reflection too. Reflection makes a mirror image. It's one type of movement for geometric shapes.
All right, well, that's it. So make sure you text or email me a picture of your notes, and then head on over to IXL and get some practice in. And feel free to reach out and get help from me if you need it. All right, see you tomorrow in math class. Bye.